Lesson 2. Reflection and Mirrors. Reading Guide. Key Concepts. Essential Questions. How does light reflect from smooth surfaces and rough surfaces? What happens to light when it strikes a concave mirror? Which types of mirrors can produce a virtual image? Vocabulary. Law of reflection. Regular reflection. Diffuse reflection. Concave mirror. Focal point. Focal length. Convex mirror. Inquiry. Why do they appear so strange? When you look in a mirror in your home, your image is very much like you. But these people are looking at their images in a carnival's funhouse mirror. Some parts of their images are much larger than they should be. Other parts are much smaller. What causes the images to appear so strange? Reflection of light. In Lesson 1, you read that reflection is the bouncing of a wave off a surface. Suppose you toss a tennis ball against a wall. If you throw the ball straight toward the wall, it will bounce back to you. Where on the wall would you throw the ball so that a friend standing to your left could catch it? You would throw it toward a point on the wall, halfway between you and your friend. Law of reflection. Like the tennis ball, light behaves in predictable ways when it reflects. Scientists often model the path of light using straight arrows called rays. The rays in Figure 7 show how light reflects. An imaginary line perpendicular to a reflecting surface is called the normal. The light ray moving toward the surface is the incident ray. The light ray moving away is the reflected ray. Notice the angle formed where an incident ray meets a normal. This is the angle of incidence. A reflected ray forms an identical angle on the other side of the normal. This angle is the angle of reflection. According to the law of reflection, when a wave is reflected from a surface, the angle of reflection is equal to the angle of incidence. Reading check. How do the reflected and incident rays differ? Regular and diffuse reflection. You see objects when light reflects off them into your eyes. Why can you see your reflection in smooth, shiny surfaces, but not in a piece of paper or a painted wall? The law of reflection applies whether the surface is smooth or rough. Reflection of light from a smooth, shiny surface is called regular reflection. Look again at Figure 7 on the previous page. The 3 incident rays and the 3 reflected rays all are parallel. You see a sharp image when parallel rays reflect into your eyes. When light strikes an uneven surface, as in Figure 8, the angle of reflection still equals the angle of incidence at each point. However, rays reflect in different directions. Reflection of light from a rough surface is called diffuse reflection. Key concept check. How does light reflect from smooth surfaces and rough surfaces? Mirrors. Any surface that reflects light and forms images is a mirror. The type of image depends on whether the reflecting surface is flat or curved. Plane mirrors. The word plane means flat, so a plane mirror has a flat reflecting surface. Figure 9 shows how an image from a plane mirror forms. Only a few rays are shown, but the number of rays involved is infinite. Notice that the image formed is the same size as the object. However, it is a virtual image. A virtual image is an image of an object that your brain perceives to be in a place where the object is not. If you look in a plane mirror and raise your right hand, your image raises its left hand. However, up and down are not reversed. Light from a surface reflects from each part of the object to the mirror. The mirror reflects the light back to your eye. Your brain knows that light travels in straight lines, so the reflection appears to come from behind the mirror. This is shown by the dashed lines. Because no object is located at the place where the image appears, the image is called virtual. Concave mirrors. Not all mirrors are flat. A mirror that curves inward is called a concave mirror, like the mirror in Figure 10. A line perpendicular to the center of the mirror is the optical axis. The law of reflection determines the direction of reflected rays in Figure 10. When rays parallel to the optical axis strike a concave mirror, the reflected rays converge, or come together. Focal point. Look again at Figure 10. Notice the point where the rays converge. The point where light rays parallel to the optical axis converge after being reflected by a mirror or refracted by a lens is the focal point. In the next lesson, you will read about lenses. Imagine that a concave mirror is part of a hollow sphere. The focal point is halfway between the mirror and the center of the sphere. The distance along the optical axis from the mirror to the focal point is the focal length. The lesser the curve of a mirror, the longer its focal length. The position of an object compared to the focal point determines the type of image formed by a concave mirror. If you reverse the direction of the arrows in Figure 10, you can see how a flashlight works. The reflector behind the bulb is a concave mirror. The bulb is at the focal point. Light rays from the bulb strike the mirror and reflect as parallel rays. Key concept check. How does a concave mirror reflect light? Types of images. When you look at ray diagrams, think about what you would see if the rays reflected into your eyes. Remember that your brain only perceives where the rays appear to come from, not their actual paths. As shown in Figure 11, the image a concave mirror forms depends on the object's location relative to the focal point. The image is virtual if the object is between the focal point and the mirror. The image is real if the object is beyond the focal point. A real image is one that forms where rays converge. No image forms if the object is at the focal point. Suppose you look at your reflection in the bowl of a shiny spoon. If your face is outside the spoon's focal point, your image is inverted, or upside down, as shown in Figure 12. Your image disappears when your face is at the focal point. When your face is inside the focal point, the image is upright. Convex mirrors. Have you ever seen a large, round mirror high in the corner of a store? The mirror enables store personnel to see places they cannot see with a plain mirror. A mirror that curves outward, like the back of a spoon, is called a convex mirror. Light rays diverge, or spread apart, after they strike the surface of a convex mirror. The dashed lines in Figure 13 model how your brain interprets these rays as coming from a smaller object behind the mirror. Therefore, a convex mirror always produces a virtual image that is upright and smaller than the object. As you just read, convex mirrors and plane mirrors form only virtual images. However, concave mirrors can form both virtual images and real images. Key concept check. Which types of mirrors can form virtual images?